Lately, the United States, and by extension, the world, has been bombarded with extreme weather that is beyond anything that many people have experienced in living memory, with everything from excessive heat, wildfires, blizzards, tornadoes, and hurricanes happening just about everywhere you look these days. But what exactly is causing this extreme weather, and what can we do to mitigate its effects? This video is the first part of a multi-part series on extreme weather in the United States and the world, and we'll start by looking at a phenomenon that is all too common at this time of summer: heat domes. Now, before we get into these metaphorical ovens, I would appreciate you would like the video, subscribe to the channel, and hit the notification bell to stay tuned for future content. Okay, so what exactly is a heat dome? Well, in order to understand that, we need to look at one of the core influences of weather in the mid-latitudes, and something that we will be revisiting in future episodes of this series: the jet stream. The jet stream itself is a fast-moving ribbon of air moving from west to east that sits tens of thousands of feet above the ground, with everything from airplanes to storm systems riding this atmospheric expressway eastward. However, for this video, it's helpful to think of the jet stream as a barrier. To the south of the jet stream, there is hotter and more stable air, and to the north of the jet stream, there is cooler and more unstable air. The reason for this is simple. Everything south of the jet stream is more influenced by the hotter air closer to the equator, while everything north of it is influenced by the colder air up near the North Pole. However, the jet stream isn't a solid wall by any means. It constantly buckles up and down at the whims of the two competing air masses pushing on it. Heat domes are formed when the jet stream buckles northward, forming a ridge that arcs over a large area of Earth's surface. Underneath this ridge, there is an extreme amount of high pressure. Under normal conditions, hot air will rise and cool air sinks, but the high pressure stops the hot air from rising further, as if hitting the roof of the dome, and compresses it back towards the ground. As the air compresses, it gets even hotter than before, and the cycle repeats, eventually leading to some absolutely brutal air temperatures. The worst part is that heat domes often tend to last a long time, sometimes for several weeks, as high pressure systems are notoriously slow to move out of the way. So, how bad can things get under a heat dome? Well, under the right conditions, heat domes can get very, very hot. One notable example of a heat dome happened in late June of 2021 in the Pacific Northwest. There, a record-breaking high-pressure system stalled over the region for several days, turning the normally cool region into a furnace. Typically, Seattle, Washington experiences highs in the mid-70s Fahrenheit, or around 24 degrees Celsius, during late June, and the city had in its entire recorded history reached 100 degrees Fahrenheit, or 38 degrees Celsius, on only 3 separate occasions. During this heat wave, however, not only was the so-called century mark reached on 3 consecutive days, the hottest of the bunch was a whopping 108 degrees Fahrenheit, or 42 degrees Celsius, beating its previous record high by 5 degrees Fahrenheit, a margin which is basically unheard of. Further south, Portland reached 116 degrees Fahrenheit, or 47 degrees Celsius, a temperature which is a single degree shy of the all-time record for Las Vegas, a city more well known for its scorching heat. Analysts would later conclude that this was a 1 in 1,000 year event, if not rarer, though it was an event made significantly more likely by climate change, which I'll touch on in a bit. Unlike more typically hot locations, homes in the Pacific Northwest often lack air conditioning, and this was estimated to lead to hundreds of deaths and thousands of hospitalizations across Washington, Oregon, and the Canadian province of British Columbia. This kind of heat isn't limited to the United States either. In recent years, typically cool locations such as London, Paris, and Rome have all seen desert-like heat on multiple occasions, with one particularly severe heat wave in 2003 leading to an estimated 70,000 deaths and completely rewriting condition standards for air conditioning in several countries. Even places more known for the scorching summer heat aren't exactly spared from heat domes, with many places in the American Southwest having public safety guidelines for when temperatures rise above 110 degrees Fahrenheit or 43 degrees Celsius. So, why are heat waves so intense these days? Well, while chance may play a part, these heat domes are undoubtedly being exacerbated by climate change. The obvious part: climate change is making everything warmer, and this includes the absolute hottest extremes. Each degree the Earth warms is another degree that can be added onto the record books, and average temperatures are also pushed closer to levels that would be considered near record-breaking today. However, climate change has another impact. It's making the jet stream more volatile, a phenomenon I'll be touching on in future episodes as well. Essentially, The other already wavy jet stream is getting wavier, with high pressure areas becoming stronger and low pressure areas becoming weaker. This, expectedly, will compress hot air even more than it already has, which makes things even hotter. Combining this with the increase in average temperatures as a whole, and heat waves are only going to get a lot more extreme as time goes on. Now, this might all seem like doom and gloom, but there are ways to make a heat wave manageable. On a personal level, it is best to secure air conditioning for your home if you don't already have it, as this will make your home a safe space in the face of hot weather outside. Overall, it's just better to avoid being outside unless absolutely necessary, as being outside in extreme heat for long time periods will increase your risk of getting heat stroke, a dangerous condition in which your body temperature rises too far above its usual levels. However, there has been concern raised in recent years over the strength of many power grids and heat waves, with Texas in particular being a weak point due to its isolated nature, reputation for extreme heat, and the fact that it has already experienced a near total collapse, albeit for the opposite reason. If a power grid collapses during a heat wave, the effects could be devastating, as millions would be left without air conditioning and be at risk of heat stroke without emergency countermeasures being deployed. In addition to shoring up the power grid, measures to combat climate change as a whole would be extremely helpful, as this would mitigate how much worse heat waves would get in the future. Overall, heat waves are brutal, but there are ways to sidestep them, and measures need to be taken to stand ready for when the next one hits and reducing the severity of heat waves in the future. And that's all I had to say about heat domes. Make sure to stay tuned, as this is just the first of several extreme weather topics I'll be covering, and they only get more ridiculous from here. As always, I would appreciate you like the video, subscribe to the channel, and hit the notification bell to stay tuned for future content. Thanks and have a great day.